Okay, good morning everyone. This is just a quick video to explain one or two of the harder sections there in statistics that I'll run through very quickly. The first one is standard deviation. So if we have a look at standard deviation here, you have two formulas for standard deviation. The first one is the more common one, which is the top one, as you can see here. Just mark this one. So this one here is when you are dealing with a list of numbers. And when you have a list of numbers, you're going to work out all the different parts in here. So in here, the symbol X is the actual number. You can see it listed there. And then mu, which is this one here, that's the mean or the average. And when it says mu, there's another X bar is another symbol which is also used. You might see that in different books, or you might see it in formula tables or whatever. But mu is the most common one you're going to see for leave insert. The second formula that you're going to use is when you have a frequency distribution table. So in this particular example here, where you actually have a list of values and how often they occur. So for example, this one, the time 0 to 40, whatever that might be a bus journey or train journey, that happened 3 times. The group between 40 and 80 happened 8 times, and the group between 80 and 120 happened 6 times. So there's a lot more numbers in here. So you're going to use a different formula for that. We're just going to concentrate on the top one at the moment and have a quick look at it. So the first thing that you're going to have to do is find the average or find the mean. Now, we have an example here, and I've picked 2 examples just to explain what standard deviation actually is. So you have to find sigma, and sigma, of course, is the symbol for standard deviation. So how do we find the standard deviation? First thing you do is find the average. So the average of all of these numbers you should be able to do at this point. I'm not going to go through it. You add up the numbers 8 plus 8 plus 9 plus 11 plus 14, and you divide by how many numbers there are, which is 5. And you end up with a mean, which we can call mu or X bar. It doesn't really matter which. The average for that works out to be 10. And then also over here in this second example, the average works out to be 10. Now, the reason why I put in 2 examples is you can see that the average of both sets of these numbers is 10, but you can see that the numbers themselves are actually quite different. If you look at the top one, these numbers are all actually quite close together. You have 8, 8, 9, 11, 14. There's not much of a range. It goes from 8 to 14. That's only a range of 6 numbers that it goes over. However, the one on the bottom, you can see the numbers are actually very far away from each other. So if you consider 9 as the middle one, you can see that 1 is a low number, 21 is a high number, but they both still have the same averages. So when you say an average of some bunch of numbers is 10, it doesn't really mean anything unless you can describe what's happening with the actual list of numbers. And that's what standard deviation does. Standard deviation is a way of explaining how far from the mean each of these numbers are. So if the mean of this top one is 10, you can say that these numbers, you know, they're quite close to 10. 8s and 9s, 11s, okay, 14's a little bit out, but they're all very close to 10. Whereas in the bottom one, if you look at 10, okay, 9 is close to 10, but everything else is very far from the mean. There's a greater spread of values. Standard deviation tells you how much the numbers that you have differ from the mean, how far away they spread. So let's have a quick look at the first example. So I'm going to take just one of these examples, 8, 8, 9, 11, 14. So let's start with our standard deviation formula. So sigma is going to be equal to the sum of the x's minus the x bars or the mu's, which is your averages. You've got to square that, all divided by n, which is how many numbers you have, and of course it's the square root of all of that. You can do this all in the calculator, which I'm going to do in the very first video of the exam papers. There's a question on it, and I'll go through that in great detail. But if you're not going to use the calculator, then you're going to have to draw it out in some sort of a table. So what I would normally do is I write down my x numbers and I create a table. I'm just going to grab a quick table here and I'll be back. So here's our table. We're going to start with x. So when you're working this out, you start on the inside of the brackets and you work your way out. So start with x, then you're going to write down mu, then you're going to write down x minus mu and work that row out. Then you're going to do x minus mu and you're going to square it. And then you're going to get the sum of the x minus mu's. Now at this stage you don't even need more lines, but we'll fill them in. So let's start off. So x, your first x value is going to be 8. Your next x value is 8. Your next one is 9. Your next one's 11. Your next one's 14. Your mu value is your average, and we worked out our mu value is 10 up here. So we write 10 in each of the spaces beside it. And then you're going to do x minus mu. So this one minus this one. So 8 minus 10, that's going to give us -2, -2, -1, 1, and 4. And then this next line, we're going to take this line and just square it. So squaring -2, we end up with 4, 4, 1, 1, 16. And then finally, the last part here is the sum of the x minus mu's squared. There should be a square in there. So in other words, we're going to take this one, this one, this one, this one, and this one, and we're going to add them all up. So we got 4 plus 4 plus 1 plus 1 plus 16 is 26. So that gives us a total of 26. Then what we can do is we can start throwing it into our equation. So our sigma is going to be equal to the square root of this whole top line here. We've just worked out to be 26. So it's 26 over n, and n is how many numbers we have, which is 5. So sigma then is equal to the square root of 26 divided by 5. So you can go over to your calculator. So we've got the square root of 26 divided by 5. Close our brackets and hit equals, and we end up with sigma is equal to 2.28. And that's our standard deviation for that long list of numbers. So let's try and take the next example. The next example is going to be a frequency distribution table, and we'll have a quick run through that. I'll write out the question, I'll do up some notes, and I'll be back in 1 second. So let's have a look at this next example. So here we've 100 students given a maths problem to solve and the times taken to solve the problem in our table. So this is a group frequency distribution. So we don't have a long set of numbers. So the first thing we've got to do is we've got to find what's called the mid-interval values. So we start with time and minutes at the top. And up at the top here, what we do is we write in the middle number of the range that you've got. So between 10 and 14, the middle number is 12. Between 14 and 18, it's 16. 18 and 22 is 20. The next one is 24. And then finally, the last one is 28. And you're going to use these numbers then to figure out your answer. So what we're going to do is, let's put in our details. So for our x numbers, we're going to put in these mid-interval values. So we have 12, we have 16, we have 20, we have 24, and we have 28. The next thing we then have to do is we have to put in mu, and this mu here is our mean or our average. So if you want to work out the mean, you're going to have to work it out on the side of the page. So in this particular example, it's going to be 12 multiplied by 13 plus 16 multiplied by 28. So again, as usual, you're taking the mid-interval values and multiplying it by the frequency, plus 20 multiplied by 26 plus 24 multiplied by 21 plus 28 multiplied by 12. And then all of that is divided by 13 plus 28 plus 26 plus 21 plus 12. And then this here is going to give you your mean. Now, when you work out the mean on that, it works out to be about 19.64. Okay, so what we're going to do over here then is you've got to put in this mean. So now in here, you would put your mean. So it's an awkward number, there's no doubt about it. So we put in 19.64 here and 19.64 here, and you continue all the way down. Your next one is going to be x minus mu. So you're going to go 12 minus 19.64, so minus 7.64. And then you continue on with x minus mu to be squared. So you would then square minus 7.64. So if we just grab the calculator, so we've got 7.64 and squared, we end up with 58.37. So we got 58.37. Now, your next one that you're going to do here is going to be your frequency. So your frequency is how many times it happened. Now, for this number 12 here, it happened 13 times. There was 13 students had this timing. Therefore, the frequency here is 13. The frequency in the next one is going to be 28. So these numbers will change all the way down. That's going to be 26, that's going to be 21, and that's going to be 12. And now what you have to do is you've got to multiply f, which is over here, multiplied by all of that in brackets. In other words, you have to multiply this column here with this column here. These have got to be multiplied. So you're going to do 13 multiplied by 58.37. So multiply that by 13, and that's going to give you 758. So 758.8. And you have to do that all the way down. And you have to do this all the way down. The next thing you do then for the top line is you get the sum of the f's multiplied by that. So this number here is f by x minus mu squared. So now what you have to do is to get the sum of the f's times the x minus mu squared is you will have to add all of these up and get your total. Now, once you have that, most of the work is done, once that total is there. And then you put it over the sum of the f's. So the sum of the f's is the sum of this line here. And you pop it all into the calculator and you end up with sigma. And you end up with a sigma value of, I think the answer is working out around 4.87 when you work down through it. So you can see that doing it this way is certainly a lot more complicated. That's why I would recommend using the calculator for this. You don't have to do it out manually. You can use the calculator. That's a perfectly acceptable way as long as you write down on the page that you got the answer via the calculator. And again, in the first video that I'm going to put up on the exam papers, I show you how to actually do it and how to create a frequency table on the calculator and find standard deviation. And it's very quick. I strongly recommend that you really know how to use your calculator for this. It will save you so much time in the exam, and it just makes more sense. There's less chance of mistake.